Welcome to Onshape. In this video, I'm going to give you an overview of how I designed the pegboard adapters. This is not a full beginner's tutorial on Onshape, as that would take a really long time, but this is to give you an idea of how I did it and the approach I took. So the first step I took was designing a standard pegboard peg based off the metal ones. So to do that, I started with a sketch. And a sketch is a 2D representation, and that's always what you start with in a program such as Onshape. Click on the front plane, because I'm going to sketch on the front plane. I'm going to right click to say view normal to sketch plane, which makes my view on that sketch. And I'm going to hide the other planes, the top plane and the front plane and the right plane. And I'm going to start sketching. And the first thing I'm going to do is sketch out a side view of my peg. And I'm going to use the line tool here, and I'm going to start on the origin. I'm going to go up like this. Okay, and I'm going to add another peg, and I'm going to make sure it's not at a center point so that it can be adjusted. Okay, I'm going to hit escape. There we go. One thing I made a mistake on is I didn't make this the same length as this, but that's okay, I'll adjust it. Now I'm going to add dimensions. And to do that, I can hit D or click this tool here. And the first dimension that's really important is the distance between these two pegs. And I took the measurements and it should be 21 millimeters. So I'm going to do that. The next thing is how far this peg goes out. And it's going to be 7 millimeters. You'll notice that adjusted automatically. Also, how far does this go up? And that is going to be 10 millimeters. You'll notice there's some interesting things up here that have kind of messed up after taking those measurements. So I'm going to adapt that a little bit to put that up the way it's supposed to be. All right. Now the other important thing is how thick is the peg? And for us, it's 4.4 millimeters. Now I could do this, make this 4.4 right here, make this 4.4 right here, and keep on going. And I am going to do that, but I'm going to do something fancy, and I'm going to create a variable. And to do that, I'm going to click the check to get out of the sketch. And I'm going to come over here to this X. If you don't see that X icon on the screen, you can always search for it using the search tools. It just means you have a smaller screen and it's not showing up. And create a variable, and I'm going to call it peg diameter 4.4. Okay, I'm going to hit the green check. And then I'm going to move it above my sketch, because variables store information so that if I have the same measurement in multiple places, I can just put that variable, say peg diameter, and then if I change it just here, it'll change everywhere. But it's important to put it above the sketch you're going to use, because otherwise it won't be available. So I'm going to get back into the sketch by saying right click and edit. And instead of 4.4, I'm going to start typing peg, and you'll see peg diameter comes up. And I'm going to put here peg diameter. And I want to make another dimension. This is also going to be the length of a peg diameter. And so is this. So why is this advantageous? Well, let's say I got the peg diameter wrong. I'm going to hit green check. So I got the peg diameter wrong, or I have different pegboard. I can just come here and change this whole thing to 10, and the whole thing will update. Now, we want it 4.4. Okay, let's go back and edit the sketch. One other thing I want here, I want to say this distance here is 8 millimeters. Perfect. And you'll notice all these lines are black except for these two. And it's because I can stretch them out this way. And I need to make sure that doesn't happen. So I need to make sure this is also 7. There's other ways to do that, but that's the easiest way that makes the most sense. So now everything is black, which means everything is constrained, which means it's not movable, and everything's the way it should be. Let's hit the green check mark and extrude it. So extruding means popping it into 3D. So I'm going to click on this tool, click here, and click on this peg too, and then I have to extrude it. How far? Well, guess what? I can use that variable again, peg diameter, which is 4.4. And there we go. Well, that's not a regular hook, and that's purposeful. I haven't added the hook on to test yet because I really only want this part. But the other thing you'll notice is that these are square, not round. And we're going to fix that by adding fillets. So we're going to take a tool here called the fillet tool, and we're going to click down here. We'll start with this one. You'll notice it turned red as I did that because this radius is too big. Okay, so what should the radius be? Well, it should be 2.2 because that will make a perfect circle. Why 2.2? Well, that's half of the peg diameter. So instead of 2.2, I'm going to use math and say peg diameter divided by 2 because that's half. And there we go. It did it. And there's my round peg. Let's do the same up here. Click on the fillet tool and let's click on all the edges we want. I'm going to change this to peg diameter divided by 2. And you'll notice as I do this, I can even do this edge, which I'm going to do. And I am going to do this bottom edge as well. Right there. There we have it. Okay, freeze for a second. Future me here. I forgot a really important fillet on this edge because without it, the peg will not fit in the board smoothly. All right, unfreeze. Now, there's one thing I did change. You'll notice this is exactly a 90-degree angle, and I actually changed it slightly to make it easier to fit in. So I'm going to go back into the sketch and edit this. And if I click on this check mark called Show Constraints, you're going to see that this line and this line are perpendicular, which means they're a right angle. And you'll notice that when I highlight this, it shows the two lines that are perpendicular. And I'm going to click on this. I'm going to delete it. Okay? Because I don't want those perpendicular. And I'm going to hit the dimension tool. And I'm going to click on this line. And I'm going to click on this line. And now it gives me an angle. And I'm going to say I want it 95. So there were some problems there, right? It turned red. It means it's not allowing me to do that because of some other constraints or rules I've applied to this sketch that contradict it. So what that means is if this tries to make this 95, it's going to break another rule I've made. So I'm going to hit escape. These two are perpendicular. And the reason they're perpendicular is because this is horizontal and this is perfectly vertical. So I'm going to take the vertical and delete that. Okay, now you'll see this is blue. And let's see if that fixes it. It does not. And that's because, see how this is red? That's vertical too. So I'm going to delete that. And now that looks much better. But not exactly, because look, the whole thing was supposed to go. Well, how can we fix that? Well, the way we can fix that is by making these lines parallel. So I'm going to click on this line and click on this line and come up here, and there's a constraint, which is basically a rule that says I want these two orange lines to be parallel to each other. So I'm going to click on that, and you notice this adjusted this length, and now they're parallel. And if I hit check, everything looks good again. Now that I have my standard peg holder, I can print it out, I can test it, make sure it works. Now I'm going to design an adapter for the slot-based pegboard. In other words, I'm just going to make a really small slot-based pegboard. And I'm going to do it in a different part studio. So how do I do that? Well, I click on this plus and I'm going to say create part studio. And I'm going to rename this slot-based mini pegboard. There's a reason I'm doing this in a different studio. I find it easier, I can orient it, and I'll put the two together in assembly and talk about that later on. So let's start with a sketch. Let's do the front plane again. Let's right click to view normal to front plane. Let's hide all the planes. And let's start with the overall size. And I'm going to come over here to the rectangle tool. I'm going to do a center rectangle. That way I can center on the origin and place it. And I'm going to size that up. And I'm going to size it 70 millimeters this way and 45. How did I know that? I did a sketch on paper, the correct dimensions. Now I'm going to create my slots. So how do you make a slot? Well, a slot is basically a rectangle and two arcs. So let's start with a center point rectangle, and I'm going to make it center down from here. And then let's make an arc on top and an arc below. And let's dimension this. I'm going to hit escape and I'm going to hit the dimension tool. And the first thing I'm going to do is say I want this here to be 5.2 millimeters. Okay. And I want from the top to the bottom here to be 15. You'll notice some things are still blue. Let's position it in relationship to the origin. I want this to be 10 down from the origin. Now that it's positioned to the origin, everything is black, everything's constrained. Now I can select all this, copy it, and paste it. And I can move it roughly to the position I want here. And I want to dimension this in relationship to this. So I want it to be 20 millimeters this way and 20 millimeters this way. Perfect. I'm going to hit escape and I'm going to select this, copy it, paste it. I'm going to move it roughly over here to the third position, click to finalize. So I want this to be 20 millimeters this way, and I want this to be 20 millimeters this way. Okay, now let's extrude it. I'm going to click here, extrude, and you'll see I have the holes because I didn't click on the slots to extrude. If I'd click on them, they would have filled in, but I'm going to unclick that. And how much do I extrude it? Well, the thickness depends on the thickness that the pegboard, the original adapters, were supposed to fit into. So that was roughly 5 millimeters. So I'm going to type in 5 millimeters. And there I have my mini slot-based pegboard. I need to now attach the pegboard hooks to this pegboard adapter. And these pegs have to be spaced apart appropriately so they fit into my pegboard. Also, I'm trying to make this system modular so that I can print the pegs separately, then I can print the adapter. First thing I'm going to design is holes here that this peg will fit into. And it's really important that these holes are spaced appropriately so that the pegs fit into my pegboard. So I'm going to make a sketch on here, click here, hit sketch, and I'm going to make it on this plane. And I'm going to make 4 squares, 2 on this side, 2 on this side. And I'm going to use a center point rectangle. And there's a reason for that. To align everything up, it is much easier to use a center point rectangle than I can use the same measurements everywhere. So let's make these rectangles. And I'm just drawing them out in the rough position. Once in the right rough position, let's add some dimensions. Again, dimension tool, go here, and I'm going to say 4.8. 4.8. Notice they moved around. Don't worry about that yet. We're going to dimension them and space them out properly. I need all these squares the same size. I'm going to just move this over so it's easier to see. I'm going to move this over into rough position like this so I can see it easier. So I could start dimensioning these all 4.8 like this, but I'm going to do this a different way. I'm going to hit escape so I have the mouse. I'm going to click on one of these sides that's 4.8 and then click on 2 sides of the other rectangles. And I'm going to hit this equal sign, which basically is saying all these have to be the same size. And you notice they all did. That way, if I change this size to 5, everything else updates. The reason I did that instead of dimensioning them all the same size is that it allows me to change one measurement and everything else update. I need to figure out the distance between these two attachment points. And this is really important because it's in relationship to the pegboard. I did some measurements, figured out, and it's 51.2 between those center points. All right, notice that shifted over. That's okay. We'll work on that in a sec. The other thing I need to do is make sure these are lined up with each other. That means they're directly under each other. And the easiest way to do that is hit escape, make sure the mouse is clicking, click on the center point here, click on the center point here, and come up to this line that says vertical, which means they're vertical completely underneath each other. See, pops right over. Let's do the same here. And you notice as I click on this, that number next to it, 2, means 2 items are selected. Click on vertical, they're directly under. Now, how far under is it? I can dimension. And I did a sketch beforehand, so it's going to line up with my hook. And their centers are going to be 22.8 apart. All right, that looks really good. The question is, why are these still blue? Well, one thing is, if I hit escape, is I can move this whole assembly up and down. Other problem I know is these aren't lined up. So let's click on these 2 center points again. And instead of vertical, there's a horizontal, and I'm going to make them horizontal. And I'm going to do the same down here, horizontal. Now, you'll notice if I move this up and down, everything moves in unison. And if I move side to side, everything moves in unison. But I still haven't defined that side to side or up and down. So I'm going to do up and down. And now I can just, on this one, dimension and say, I want this 5 millimeters from the top. All right? Now you notice the top lines are black, but I can still move it side to side. So what do I do there? I could just sort of eyeball it, make sure it's not overlapping with any of the slots. I'm going to just view normal to sketch plane to make sure it's crystal clear. But I want to do something a little cleaner, a little more accurate. So what I'm going to do is I'm going to click on this line tool, and I am going to click on this construction tool. What that means is when I draw a line, it's going to be dotted, which means it's just used sort of as a guide. And I'm connecting these 2 dots, and I'm connecting these 2 dots. And the reason I'm doing that is to get a point in the center. It doesn't automatically create there, but I can put a point. See this point here? I can put that point right in this center. See how that yellow dotted line is there? I don't want that because that's with the origin. I want this square where they intersect. Now I click on this point, I click on that point, and I say vertical, and you notice everything is defined. Now if I try and move anything, I can't. All right, so now that I have my sketch for my holes, let's extrude it. I hit check. I'm going to hit on this, click on this sketch, hit extrude, and instead of add, I'm going to say remove, and there are my holes. Instead of blind, I'm going to go up to face, and I'm going to click on the back of this. That way, if I change the thickness, everything automatically updates. Now, these are rather close to each other, but they will work. This will be strong enough once these pegs are filled in. So now I have to make the corresponding parts that fit into these holes on the peg. I've sketched this out on paper. I have my dimensions right here. I'm going to click on sketch, click on the surface, and again I am going to use the center point rectangle because I want to be measuring from 2 center points. Now the problem with that is, how do I know this is a line center here? Well, I'm just going to do it roughly estimate. I'm going to make 2 rectangles, one there, one there. I'm going to hit escape. I really do want this aligned center, so what I'm going to do again is click on this line, click on construction, hover here, see that orange square? That means I'm in the center, and I'm going to put this center line straight up. So I'm going to click on this center point in this center line and say coincident, which means they're touching. And then I'm going to say this point in this line and say coincident, and means they're touching. Now I can start dimensioning things. The height I want this to be, I'm going to hit D for each one, is 4.4. If you remember, I made 4.8 for the whole size, so I'm making it 0.4 smaller. That's to adjust for the the inaccuracies of the 3D printer, otherwise known as tolerances. This distance has to be the same as I did for the holes. So this from here to here is 22.8, if you remember, in the center. Now, this is too high. How do I deal with that? Well, I'm going to hit escape to get the mouse tool. I'm going to click on this point and click on this point down here. I'm zooming in here. Let's see if it'll let me. Nope, it won't let me. So I might have to move things first down a little bit so I can get to it. All right. Now I can click on that point, and I'm going to say coincident, means they're touching. That way it's lined up right with there, and everything is black, which means everything's defined. Let's extrude this. Click the check, click extrude, and remember the thickness was 5 millimeters, so I'm going to do 5 millimeters for the distance. All right, now those should fit in the hole, but I want to give a little wiggle room to this. Let's create a slot there. So I'm actually going to go back to Sketch 2, right click on it and say Edit. And I'm going to do another rectangle here, and I'm going to dimension it. I'm going to make it 1.5. And I'm going to do the same thing here. 1.5. Hit check. You notice with my extrude now, it just did these two sides with a hole in the middle. That's going to offer some flexibility, but I don't want these this long. So what do? Well, I can do another extrude, and if I click on the sketch and say so sketch, I can click on this part in the middle and say I want that to go only 2 millimeters up. Now I have a little more substance down here, and these slots aren't as deep. I can then click on hide the sketch so it doesn't distract me. All right, so I got my clips and I got my holes. But how do I know everything's going to fit correctly and what it looks like all together? Well, it's much easier to test this out in CAD before wasting time and material printing it. And Onshape has this really great feature called an assembly. This is a fairly simple assembly, but it will show you the basics of how an assembly works. So the first thing you do is insert the parts. So I'm going to insert slot base pegboard and 2 clips. Okay, and I hit the green check. They're all named part 1, which is not good, so we should rename these. Why are they named part 1? Because back here, they're all named part 1. So I should have renamed this earlier here to pegboard adapter, and this one renamed to clip. If you know that, it renamed them here as well, which is great. So the first thing I'm going to do is make sure that this adapter doesn't move. So I'm going to right click on it and say fix. Now I could have fixed it to the origin, but for this case, it doesn't really matter. The next thing I'm going to do is I'm going to roughly place these by hand. So I'm going to click on this one. I am going to orbit around so that I get the right rotation. Rotate it 90 degrees. And I can move it roughly into place. Okay? And I'm going to do the same thing here, using these tools, moving it roughly into place. But roughly is not good enough to see how things fit. And as you can see, this is really rough. There's a really cool feature in assemblies called mates, where you can mate 2 things together. So what I really want to do is say this part here is attached to this part here in the hole. And there's something called a fasten mate. So if I click on a fasten mate, it'll say, what do you want to fasten? I'm going to connect the valley of this piece to the front of this square here. So I'm going to click on this fasten mate, and I'm going to click on the center of the valley there to make my first mate connector. And now I'm going to connect it with the front here. I'm going to hover over here. There's this circle with a plus sign in the middle, but when I go over it, I can't get it. Well, there's a keyboard shortcut for that. If I hover over this surface and hold Shift S, I can now snap to any point on this surface. So I'm going to click there. and you'll see it pops in there. Now, if you remember, that valley is actually 3 millimeters below this top part right there. That's why the peg is sticking out. We can fix that with an offset. So I'm going to come up here, hit offset. Well, what axis do I offset on? Well, if I zoom in here, I can see the different color axes. Z is in blue, Y is in green, and X is in red. And I want Z, because it goes back and forth this way, and I want it to be 3 millimeters. Oops, the wrong direction. I went 3 millimeters forward. If that happens, no problem. Just put a negative sign. Don't have to be negative about this. Just put a negative sign. That looks great. I'm going to hit the green check mark. Now I'm going to do the exact same thing on the other side. There we go. We have them both aligned. Now I'm able to see that there is slight space around the adapters and pegs. So this is my tolerance. This gives me a little extra room for when the 3D printer prints something a little too big or a little too small, that it will fit in together nice and snug. I also notice that these are lined up perfectly with each other. So I am now good to go. Remember, when I print this, I'm going to print these as two separate parts. I'm going to print it as this part laying flat, so it doesn't need supports, and this part laying flat. In other words, it's a modular system. And the great thing about it is, with these pegs, I don't have to use this pegboard adapter. I can use this same system to create a shelf, to create a container to hold pencils, etc., etc. Good luck in what you do. Don't forget to learn and create every day.